Hello, today we're going to talk about classes. Classes are used when we want to define our own types of objects. So they're basically like custom made objects. It can be a bit abstract at first, but it's really useful. So pay close attention today and sort of try to understand what's happening. They sort of, when you create them, the thing that's useful about them is that you can sort of both they can both contain data, which are accessed through attributes, and they contain functions which are specific to the class that you created. And these functions can sort of draw on the data you already stored in the class. That may sound a bit wishy-washy, but I promise it'll be easier to understand once you have an example. A common way to use these classes when you define your own classes when you're solving a model would be to like define your model as a class, and then all the parameters are attributes, and sort of the operations you need to do to solve the model will be the methods of the class. And then you can sort of, there are other ways to do it, and sometimes you will have agents as classes or like specific subparts of the model as classes. But that's one way, and sort of gives you an idea what the approach is to using classes. Then you can both have the parameter space and the operations you need to do solve the model inside the same classes. So we start with an example of a class called human, which is just a silly example where you sort of take in a human, you store the name, height, weight, and then it can calculate your BMI. So what's happening here exactly? When you create a class, you write class and the name of the class. It's common to capitalize the first letter in a class, but that's sort of not that important. And then you have the brackets and a colon. What you always do when you define a class is you want to define the method init, which is defined by writing two underscores, underbars, and init and two underbars. Sort of these inside classes, whenever you see a function or method with these underbars, it's sort of a built-in Python functionality. So you define it with a specific name with these underbars, and then it's called during like when you call the class at some specific point. For example, init is just called when you initialize the class. So when you want to create an instance of this class. And what I mean by that is sort of a class can also, it's like a function where you create the class here, but it's not actually created until you call the class, and then you create an instance of the class where you can have specific data, and you can have specific data, but all the methods are sort of the same for different instances of the class. So here we define the class and use this init, this initialize, which is sort of the first function you call to create an instance. All the methods starts with the argument self, which is the class itself or the object itself, and then you can have different variables here, just like a normal function. Here we just define name, height, and weight. And what this initialization function does is very simple. It sort of just stores the inputs as attributes, so we can use them for later, basically. So they create an attribute called name, and then you store the name you have inputted, and the same for height and weight. So now we have a class with attributes, and now we want to create a method or function to do some calculations. And in this example, we're calculating the BMI, the body mass index of this person. And here, when you create this function, because you already stored the weight and the height, then you only need the self as an argument to do this calculation. So the human only needs, and they're sort of automatically an argument. But you sort of only need the data from self. and you just calculate the BMI using a formula, and then you can access from self, you can access the weight and the height, and then you do the calculation, and then you return BMI. And then we define another method, which is just this print BMI, which just prints the BMI. So it calculates the BMI here by calling this method on self, and then it prints it. Yeah, and then here we use it. So this is Jeppe has made this example. So we create a human called Jeppe, which has a height of 182 and weighs 80. So this is in centimeters and kilograms, but not important. First we print the type, which is just it's a human class, because it's sort of the type is the class. And then this main is just that it's created, or it's defined here in main. This is sort of only, it goes a bit back to the global local scope. It's not really important, but it's self-defined. And then you can print a specific attribute, and you access them using this dot notation. So we created Jeppe up here, and then if we want to know what his height is, then we just write Jeppe.height, and then it prints this 182 that we put in as the argument for height. Then it goes in here, and then we can access it. And we can also calculate the BMI just by writing Jeppe.bmi, and then because it's a method and not an attribute, then we sort of need the brackets like when you call a function. Yeah. This is sort of the same, and yeah, you access attributes using dot notation. You can also change attributes. So here we initialize Jeppe with 182 height and 80 weight, and created Jeppe. But you can actually, when you access the attributes, you can also change them. So if you write Jeppe.height is equal to 160, then you're changing the class Jeppe that we have already created. So here now his height is 160, and because he has the same weight, then his body mass index increases substantially. Another way to access these attributes is to use setAtt for set attribute and getAtt for get attribute. Yeah, that's actually an error here. Just fix that. And the way you do that is if you wanna set an attribute, so that's what you're doing here. You're changing the attribute. Then you write set attribute of this object, and then it's the attribute you want to change, and then you want to write what you want to change it to. If you want to get the attribute out of the object, then it's just get attribute, Jeppe, the object, and then the attribute you want to get. Yeah. And then that's operator methods. That's sort of another one of these underbar methods that you can define. For example, plus. So if you add two objects together in Python, so it's any objects, then they will have sort of this add method, and using plus will automatically call the add method when you're adding two of the same types of object. So here we define a class called fraction with a numerator and a denominator. And then there's this string object is another one of these sort of built-in name objects, which is just the string presentation of the class. So if you want to print it, what will it print basically? Because you can see here if we print Jeppe, then it will sort of give us no information at all. It will just tell us, yeah, this is a human object. So the class you created earlier. But if we print this, as you'll see later, then it will actually print this string which will show us the numerator and the denominator. And then we have defined this add function, which is when you add this method onto another, this object onto another object. And it's sort of called automatically when you use plus. So what we will do is we'll use this formula, which sort of say if you have a fraction you add to another fraction, then the true value is this, a times d plus c times b divided by b times d. And that's just what it does here. It creates a new numerator and a new denominator. So the new numerator is this a times d plus c times b, and the denominator is just b times d. And then it creates a new fraction from the two previous fractions. So here's an example. So we create a fraction which is 1 over 3, and then when we print it, then it actually prints 1 over 3. So we sort of, okay, that's what it is. And now we want to use this addition method. So we create 1 over 3, and we create 2 over 5, and then when we add them together, Python will automatically call this method and create us a new fraction, which is 11 over 15, because it's sort of it's divided by 3 times 5, 15, and then sort of also exploded these to 11, as you can see here. And it's again this fraction type, so we get the same kind of fraction. You can also do it like directly by calling the method, but it's much nicer to just write plus. We have not defined how to multiply fractions yet, so Python will not know how to do that. So if we try, then it will throw an error. So we use this try except thing. So we try to say, okay, we create a set which is x times y, print set, and then Python will be like, yeah, I don't know how to do that with this type. So this is actually a task. It can maybe be a bit daunting if you're sort of if you're a little bit confused about these classes, but try to give it a look. So the task is to implement multiplication for this fraction class. What you can do is you can write it here, or you can just copy the whole thing and put it down here, and then write a new method which performs multiplication of two fractions and create a new fraction. So the mul is the name for multiplication. You can also just create a method called multiplication, then it just won't have you won't be able to write it like this. You would have to write set equals x dot multiplication of y. But if you call it mul, then you will be able to write it like that. So give it a go. So the thing is, if you have a multiplication here, then you will just get a times c divided by b times d. So pause it now, give it a go. Otherwise, I'll show the answer. Cool. Hopefully you got the right answer. Otherwise, I'll show you here. So what you do is you define a new method called mul with a new numerator, which is just the multiplication of the two previous numerators, and the denominator was also the multiplication of the denominators. So here's just an example to see that it works, that you sort of get 2 divided by 15 here. So here I have an extra example where we create an economic agent as a class. I'll try to keep it as simple as possible, so just focus on what class is. So we have a very simple economic agent with a conductor's utility, has an exogenous income and faces prices, and then we'll just try to maximize utility based on that, sort of deciding how much of good 1 should I use and how much of good 2 should I use or buy actually. And we already know like the analytical solution, and we'll just use the analytical solution here. We know that since it's Cobb Douglas utility, and that they will always spend alpha share of the income on good 1 and 1 minus alpha on good 2. So we're going to use numpy just because we need to initialize the solutions as being not a number, so it's not really that important. Okay, so we have this, it gets a bit larger, but don't worry, it's not that intimidating. So now we created as an init again. Just call it agent. We just use quarks, which are these keyword arguments, which I've shown you in another video. Again, that's not really important. It's only if you want to change the default values. So here, in the previous examples, you'd had to input arguments to define your agent. Now we just say, okay, if you input nothing, then we just create a default agent, and we're going to call him Asger. His alpha is going to be half. His price is going to be 1 and 2. His income is going to be 10. And we don't have a solution yet, so that's why we input not a number. And we have this Boolean operator to say, okay, have his problem been solved? No, it has not, because x1 is an arm. And then this loop basically just extracts the keyword arguments, and then you set the attributes of the agent. So for example, if I wanted him to be named something differently, then I could here, when I initialize the class, then I can just write name is equal to Søren or something. That's not really the most important thing here. It's just it's a nice way to sort of have default values and then be able to change all of them. We also have a string representation. Don't go through this code unless you are interested in f strings. There's another video for printing nicely. But basically this method just prints like a lot of information about the agent, like the name, the income, the alpha, like all of the things we just defined. It just prints them out nicely. Then we want to define the utility function of the agent, so we can always know what their utility is. And we define an expenditure function, so we know how much they're spending on the goods, given that we have, or not given that we have a solution. So here we take in x1 and x2. And then we define a solution function for when we want to solve the agent's problem. And because we have the Cobb Douglas formula, then we just write it like this. So very like straightforward. Alpha is income divided by price, and x2 is 1 minus alpha times income divided by price. And then we have a print solution function, which is after we solve the function. Then we want to print the solution in a nice way. Okay, so now we create an agent called Asger, and then we can see when we print him, then it calls this function, and it's nice to have a sort of a representation of what does your class contain. So we can see that his income is 10, his alpha is a half, and his price is 1, 2, and the optimal consumption of x1 and x2 has not been found. But then we call the solve method, and then we print the solution. Then we just use the formula here, which are taken from the Cobb Douglas solution, the analytical solution, and then we just print the solution, and we can print his utility, and we can print his expenditure. So that's what happens here. So you already have solved the model. So now x1 and x2 are attributes of the model or of the agent. And then we create this text where we use f strings. So I won't go too much into f strings. So that the idea is just, if you have an x string, then you can, inside curly brackets, call on variables. So here we just call on self.x1, and then we'll sort of have the string representation of that, just a number you get out. So we print, okay, that's what x1 and x2 is, the utility. Then we can just directly call the utility function and insert the solution, the optimal x1 and x2, and we can also see the expenditure by calling on the expenditure function. Yeah, and you can sort of you can also do this directly. So you say asker.ufunc, and then we saw, okay, the solution is this. What if I lower x2 somewhat, then the utility will be lower. Stuff like that. Yeah. Of course, this is a very simple model. You wouldn't have needed to have a class to solve it, but it's still it's pretty nice that you could have all the parameters and the information you want like inside the class, and you can still have the solve function also inside the class and have it be specific to this class. So I can create a new agent called Søren, and then I can sort of say, okay, he actually has a much larger income, for example. And then when I print Søren, then you can see, okay, he's okay, I should also give him the name Søren. I'm using the keywords arguments here. So okay, we have an agent called Søren, and he faces the problem that he has huge income compared to the Asker agent, but he has all the same prices and the same alpha. And you can see that when you solve Søren's problem, then his optimal consumption is just gonna be much larger, which makes sense. And his utility is also gonna be much larger, and he's spending all his income, as you would expect, since there's no negative utility from spending your income. Okay, cool. That was the main things I want to teach you today. So the class is your user-defined type. It has attributes, which are values encapsulated in the class, and it has methods, which are functions in the class. Operators are fundamentally defined in terms of methods. So this is actually, I didn't speak that much about it, but this plus and multiplication sort of, every time you use that, you're calling the add method of whatever type you're adding together or multiplying. So this is sort of, classes are user-defined types, but when you use other classes in Python, especially if it's imported packages, sort of, they're all defined like this. So it's really good for you to know how to do this, because it's useful for creating or solving models, but it's also really useful for you when you're getting a bit further and you want to read documentation and read what other people have done, because typically they will have created some classes along the way. So that's the main thing. So if you're totally trying to comprehend what's everything that happened, then just pause the video. If you're ready to learn something more, then I want to talk about iterators a bit extra, which goes back to loops and containers. Just pause the video now if you're not interested. That's totally fine. So let's go through this quickly. If we go back to loops, a list is said to be iterable because you can loop over the elements. You can iterate over them. So here you just going in a for loop over the list, printing the element of this list. But you can also use an iterator, which is, for example, this range. And the cool thing about the range is that it's not a list, so it doesn't store like all the elements. It sort of just creates them along the way as they're needed. So you don't have to store, potentially you could have like a crazy large list. And Python would prefer not to store it all at once, but sort of just create each element at each point of time. And that's what sort of happens here. So you can create the same loop, but you don't have to store all the elements. And you can access an iterator using the iter function first, then you create it, sort of define it as its iterator. Not sure exactly what you would call it. Yeah, I'm not certainly sure what the terminology is, but the point is that you create this iter object, and then you can just call the function next on it. So instead of looping, then you're just getting the next object. Yeah, so it's a range iterator object. And then this is sort of the same loop, you're just doing it manually. This is just sort of to see what's happening. You're calling, each time you're calling next, then you're sort of going through the next loop, and Python just sort of calculates the next number. 0 to 4, yeah. And yeah, the main benefit is that the list is never created, which can be really useful in terms of memory. Yeah, and we can create your own iterator class when needed. So this sort of combines the class we've just learned about and loops and iterators. So here we define a class called range two-step. The idea is just to start from some point, go up to a big N, and with 2 steps at a time, so you add 2 each time. This is of course much easier done just using the range, but for example's sake, say we needed this, so you create the init, which has a small I, so you start at 0, and then you go up to big N. And the iter object of this class is just the class itself, and when you call next, then you we start here. When you call next, then you just add 2 to I and return the old I. So you update the I in the object or in the class or the object, but you return the previous I. That makes sense. It's easier to show you. And then it just has like a stop condition here. So if I reaches N or is above N, then you stop the iteration. Alright. So here we create the iter object, and then when you print next, you start from 0. So you print 0, and then you update I, and then the next you update. So when you update I, you add 2, so you have 2, and then at the next step you print 2, but you update I, so it's now 4, and you can see, I think if I call it directly, then it will know that I is now 6. So you print next, and it will return 4, but it will also have updated the I to become 6. And then you can use this iteration object in a loop. Yeah. So that was all for today. Thank you for watching.